Section 4.8, Rolle's theorem, the mean value theorem. Let's look at Rolle's theorem first. It says, let f be continuous on the closed interval AB and differentiable on the open interval from A to B. If f of A is equal to 0 and f of B is equal to 0, then there's at least one point C in the interval AB such that f prime of C is equal to 0. What in the world are they saying here? I think it's important so we could use this to work our homework problems. Alright, let's see. Here's basically what they're saying. Let's suppose I'm looking at some closed interval from A to B here, okay? Then they're saying that if f is continuous on the closed interval and differentiable on the open interval, and if f of A is equal to 0 and f of B is equal to 0, what does that mean? That means I have a 0 at A, I have a 0 at B, okay? Now, if my function is continuous and differentiable, then my function might do all kinds of stuff like this, okay? But they say that it has zeros at A and at B, so it must hit the x-axis at A and at B, okay? Then it says if all that happens, then there's at least one point C in the interval AB such that f prime of C is equal to 0. So they're saying in this interval, there must be at least one point that they're calling C to where the derivative is equal to 0. Well, I would say like that would be a point like right here, okay? And why would I say that? Because that point on the curve right here is where I have a derivative of 0. So that would be like a C value, okay? Another point on this curve that I drew would be right here. There's at least one point C. Here would be another C value. Maybe I'll call that one C1. Maybe I'll call this one C2 to where my derivative is equal to 0. There's another value up here. Maybe let me call that one C3 on the x-axis to where my derivative or my slope of my tangent line is 0. So what's it saying basically? If you have a 0 at A and a 0 at B and you have a continuous differentiable function, okay? It's either going to go up, down, or maybe both or whatever, okay? But you're going to have at least one point C where the slope of the tangent line is 0. Well, let's work our first example here, okay? What's the first example read? It reads, find all values of C in the interval that satisfy the conclusion of Rolle's theorem. Alright, so let me see what I have here. I have f of x is equal to the cosine of x. In my example, I have f of x is equal to cosine of x, and then they give me the interval from pi over 2 to 3 pi over 2. All right. And they want me to find all values of C in this interval that satisfy the conclusion of Rolle's theorem. Well, let's check what we call a hypothesis of Rolle's theorem, okay? What was the first thing it talked about? If f is continuous and differentiable, right? Isn't a cosine function continuous? Think about it. Isn't it also differentiable? It doesn't have any what? Sharp corners or cusp or anything like that, right? So it's continuous and it's differentiable. Let's also check if f of A is equal to 0 and if f of B is equal to 0. Well, what's f of A? That means my function evaluated at this endpoint. What happens if I plug in pi over 2 right here? What's the cosine of pi over 2? 0, right? This one checks out. How about f of b? What's f evaluated at 3 pi over 2? Cosine at 3 pi over 2. My cosine at 3 pi over 2 is also 0. So it checks out, okay? Then what does it say? If all that checks out, it says, and there must be at least one point C in the interval to where f prime of C is equal to 0. So let's find that point C. So where f prime of C is equal to 0. So let's find f prime first of all. Now f prime of x is equal to negative sine of x, right? Now, they say there's at least one point C to where f prime of C is equal to 0. So I'm just going to replace x here with C, which replaces this x also at C, okay? Now, what do I want to find? I want to find that point C to where f prime of C is equal to 0. Here's f prime of C, negative sine of C. Let's find where negative sine of C is equal to 0. Divide by negative 1, and you get sine of C is equal to 0. Now, what's that value of C? Where is the sine function equal to 0? Sine function is equal to 0 what? At 0 radians. Where else? Pi radians, 2 pi radians, 3 pi radians, and so forth, right? And also at what? Negative pi, negative 2 pi, negative 3 pi, so plus or minus all those, right? But what am I looking at? I'm looking at only the ones that fall between negative pi over 2 and 3 pi over 2. So only the ones that fall between a half pi and 1.5 pi, right? Which one or ones of these, which ones here fall between a half a pi and 1.5 pi? Only what? Pi, right? So my only answer here is that C value is equal to pi.